Welcome to The Explainer. So today, we're diving deep into this massive paradigm shift we're calling Software 3.0. You know, if you've been anywhere near the tech world lately, you've probably heard a staggering amount of noise and, frankly, hype surrounding AI coding. But today, we're going to cut right through that. We're separating the hype from the actual, nuanced operational reality. We're going to look closely at how AI is practically rewiring how enterprise software is built, the very real impact it's having on developers on the ground, and yeah, the massive risks that are hiding just beneath the surface. Okay, here's our roadmap for today. First, we'll do a quick welcome to Software 3.0. Then, we'll compare vibe coding versus agentic engineering. After that, we'll look at the 100x engineer reality, tackle the massive legacy migration, and finally, wrap things up with governance, security, and liability. Let's get into it.
Now, the core philosophy of our current moment is actually really fascinating. There's so much fear out there about, total human replacement. But the data and the frameworks that are actually working point to a totally different reality. We're looking at human augmentation through what experts call an autonomy slider. So you aren't being replaced by a robot. No, it's more like you're stepping into an Iron Man suit. You get to literally dial up or down the level of agency the AI takes on.
All right, Section 1. Welcome to Software 3.0, the paradigm shift of intent as computation.
So, to understand where we are, let's look at where we've been. In decades past, we had Software 1.0. This was your deterministic C++ or Python, hard coding, rigid, explicit logic, step by step. Then, in the 2010s, we shifted into Software 2.0. That was all about training neural networks and curating huge data sets to optimize mathematical weights. But now, welcome to the 2020s and Software 3.0. Natural language, primarily just plain old English, is actually operating as our direct core computational interface. It's wild to think about. Under this new mental model, you kind of have to completely reframe how you think about a computer. In Software 3.0, the model weights of the large language model, they essentially act as the CPU, and the context window, that functions as your RAM. Programmers simply aren't writing those intricate manual implementation details anymore. Instead, you describe your goals, you set your constraints, you establish your intent, and then you just let the AI dynamically generate the computational pathway.
But you might be wondering, why does this work so flawlessly for coding, but then fail so spectacularly in other areas? Well, it all boils down to the verifiability thesis. This is a concept articulated by Andrej Karpathy, and it basically explains that AI absolutely excels at math and coding because a compiler or interpreter gives it an instant, objective, binary feedback loop. The AI knows immediately, right then and there, if it succeeded or failed. But put it in a highly subjective domain without those perfect verifiers, and well, AI capabilities remain incredibly inconsistent.
Moving on to Section 2, Vibe Coding versus Agentic Engineering, the Production Divide.
As natural language programming exploded, we saw two totally distinct methodologies emerge. On one side, you have vibe coding. This is super ad hoc. You write a prompt, you hit accept all, and you just run it to see if it works. And sure, it's high momentum, but it is an extreme security risk, and it breaks down completely once you get past a few thousand lines of code. On the flip side, you have agentic engineering. This is the enterprise-grade reality. We're talking formal design specs, multi-agent swarms where different AI personas actually check each other's work, strict CI/CD pipeline integration, and explicit human checkpoints. So, casual, reckless vibe coding, great for a weekend prototype, but enterprise software? That demands rigorous, supervised architecture for sure. And here's exactly why vibe coding fails in production. Context collapse. Imagine you're just having an endless ad hoc chat with an LLM. Eventually, the model simply forgets the early architectural boundaries you set up hours ago. It starts generating contradictory logic. Without the strict orchestration of agentic engineering, the AI literally loses the plot and spits out a mountain of unmaintainable spaghetti code.
So, just how risky is this? Well, empirical studies from Veracode put a hard number on it, and it's a bit scary. They found that a staggering 45% of heavily AI-generated code contains exploitable security flaws. Almost half. Vibe coders often unknowingly accept hallucinated package dependencies, and malicious actors know this. They can easily exploit it by creating poisoned libraries that match those exact made-up hallucinations.
Okay, Section 3, the 100x engineer reality, swarm commanders, and junior penalties.
So, is the mythical 100x developer actually real? The short answer is yes.
But raw typing speed, that's completely dead. The modern 100x engineer is what the industry is now calling a swarm commander. They delegate all the tedious scaffolding and boilerplate to AI agents, saving all their cognitive energy for high-level system design and rigorous constraint setting. They're orchestrating multiple agents all at once. Check this out. During the AWS Unicorn Gym in Tokyo in 2026, teams using these structured AI orchestration loops actually compressed a massive 6-month enterprise project into just 48 hours. I mean, that is the literal definition of a 100x multiplier.
But here's the totally non-obvious reality about that multiplier. It is not evenly distributed at all. Current organizational data shows us that senior developers ship AI-assisted code 2.5 times faster than junior developers.
Researchers are calling this the junior developer penalty. You see, AI doesn't magically democratize coding skill. It amplifies existing expertise. Senior engineers get massive leverage because they have like a decade of deep architectural intuition. They know exactly when an AI is leading them down a structural dead end. Junior developers, on the other hand, are seeing only about a 13% productivity boost. And why? Because they just don't have that foundational intuition yet, which leaves them totally unequipped to audit complex cascading errors when the AI messes up.
And that brings us to a really massive psychological bottleneck. Think about it. If one senior engineer is spinning up 10 parallel AI agents all day, eventually they have to sit down and review all that machine-generated code. Engineering managers are seriously raising the alarm right now about code review fatigue. The cognitive burden of constantly paging in deep architectural context to review mission-critical AI code is leading to severe mental exhaustion. It's gotten so serious that industry leaders are actually proposing mandatory rest periods and shift limits, literally exactly like we have for commercial airline pilots, before a human is legally permitted to merge AI-generated critical infrastructure. Wild, right?
Let's look at Section 4 now, the massive legacy migration, rewriting the digital infrastructure.
Zooming out from the individual developer to the big picture macro scale, analysts estimate there is a mind-boggling $1.5 trillion backlog in enterprise software maintenance and modernization. Organizations aren't just using AI to build cool new apps. They're deploying entire autonomous engineering swarms to ingest old legacy code bases, resolve decades of tech debt, and systematically rewrite clunky monolithic apps into sleek, modern AI architectures.
But to pull off a migration of that massive size without causing, a catastrophic system failure, entirely new operational frameworks are having to be born. Take the AWS AI-driven development lifecycle, for example. It completely replaces traditional agile sprints with strict human-AI collaboration. In step 1, inception, the AI analyzes and plans, but humans hold a mob elaboration ritual to actually validate the proposal. In step 2, construction, the AI writes the code, but humans have mandatory intervention checkpoints so they don't just become passive approvers. And finally, step 3, operations, relies on continuous systemic observability platforms to trace every single autonomous decision that the AI made.
However, as these systems build and rewrite other systems, we are facing a massive existential risk. It's known as model autophagy. Basically, as the internet's reservoir of high-quality human data depletes, AI models are increasingly training on synthetic, AI-generated outputs scraped right back off the web. If they start ingesting their own unchecked vibe code, experts warn we could see an Ouroboros of mediocrity. It's a recursive degradation where unchecked synthetic data literally poisons the well for future foundation models.
All right, our final section, Section 5. Governance, security, and liability, the unresolved stakes. Enterprises are absolutely scrambling right now to update their IT governance. I mean, it's no longer enough to just scan static code. You actually have to monitor live, autonomous agent behavior. To stop employees from accidentally leaking proprietary code through shadow AI, companies are routing all traffic through centralized AI gateways. They're enforcing incredibly strict zero data retention clauses with their vendors, and most importantly, they are implementing bounded autonomy. Using identity and access management, they make sure an AI agent might have permission to draft the code, but it is cryptographically barred from pushing anything to production without multi-factor human authentication.
And the big reason they are enforcing bounded autonomy so strictly is because of something called the liability collapse. In traditional software 1.0 and 2.0, accountability was perfectly linear, right? If a human wrote a bug, that human owned the failure. Simple. But in software 3.0, when you're dealing with massive multi-agent swarms, accountability becomes completely blurred and dangerously diffused. So I'm going to leave you with this final provocative thought to chew on. Let's say an autonomous agent hallucinates a highly vulnerable dependency, somehow bypasses an AI-generated test suite, and pushes code that causes a massive enterprise data breach. Who takes the fall? Is it the software vendor? The original prompt engineer? The tired human who just passively clicked approve because of code review fatigue? Until artificial intelligence can legally carry liability, how fast can we truly, safely deploy these autonomous swarms? It's a lot to think about. Thanks for joining me on this explainer, and I'll catch you on the next one.